Okay, boys and girls, welcome to Unit 1B. And in this unit, we're going to continue our look at functions, piecewise functions, and this time we're adding some quadratic functions to our piecewise function. But our bell work today is the first page in your packet, so I'm going to ask you to pause the video for about, as long as it takes you to finish this and to finish the bell work on page 1. Pause the video and come back. Okay, boys and girls, welcome back. Let's just go over the answers to this. So the first part of this is that there is a flat fee for the first 20 passengers. So if there's a flat fee for the first 20 passengers, that would just be $250. There's no X because it doesn't matter how many people you have, you're just going to pay $250. So our piecewise function, the smallest number of people you'll ever have is 0, and the greatest number in this first one would be 20. And the reason I didn't include 0, because if you have 0 people, you're not going to pay the $250. So you have to have at least one person to pay that. And then our second one, the additional passengers are $15 per person, so that's going to be our slope. Remember from what we did in the last packet, we have to subtract the 20 people that have already been accounted for in the $250, and then we have to add the $250 that we paid originally. And our second piece goes from 20. I'm not including that because it's included here, but the most passengers you can have is 50, so that's the most we can have. So that's what that function looks like. And then to graph it, I've already graphed it. Again, I put an open circle on 0. For the first 20 people, you pay $250. And then the 50th person, if you do the math, the 50th person you'll pay a total of $700. The range is the Y value. So 250 is the smallest amount you'll pay. The most you could pay is 700. And how much would you pay for 27? We'd put in 27 for X. So 27 minus 20 is 7. 7 times 15 plus 250 should give you about 355. Okay, so let's go ahead and start our lesson today. Our objective today is simply to graph an absolute value function. And we're going to look at some characteristics of this absolute value as well. So the parent function of an absolute value is y is equal to the absolute value of x. That's the parent function. And then from that, we're going to kind of move it left, right, up, and down. And the graph of a piecewise function is what you see here. This is a graph of a absolute value function. It looks like it's a V-shaped function. We can write this as a piecewise function, noticing that there's two pieces, two linear functions that converge at what we call the vertex. This is called the vertex. And so it's broken up into pieces by the vertex. This first piece is simply negative x. It has a slope of -1 and a y-intercept of 0. So that first piece is just negative x. So we would say y is equal to negative x when x is less than 0. The second part of this piecewise function is simply x because, again, it has a slope of 1 and a y-intercept of 0. And that occurs when x is greater than 0. Now, I could have said just made this less than and made this greater than or equal to, because it doesn't matter. They're both on 0. So looking at this, what would you say the domain of this function is? We could say that domain is negative infinity to infinity. And that's true for all absolute value functions. Absolute value functions. All absolute value functions have a domain of negative infinity to infinity. Its range is based on its vertex. Vertex. So what is the smallest y value? The smallest y value is 0, which is included, and then it goes on and on forever, so it'll be 0 to infinity. When is it increasing? It's increasing when the slope is positive. It's decreasing when the slope is negative. So it's increasing from 0, it's increasing here, so it's increasing from 0 to infinity. It's decreasing, the slope is negative, it's saying it's going to follow this pattern, so it's going to be decreasing from negative infinity to 0. And technically the 0 should be in parentheses because at 0 is neither increasing nor decreasing. And the vertex, we've already talked about it, the vertex is this point. It is either the lowest or the maximum point of the graph. So this is my vertex. So in this case, my vertex is 0, 0, and it is the lowest or most maximum point on the graph. Some people call it the turning point because it was negative and then it went positive, so you can look at it either way. The axis of symmetry is an imaginary line that divides the function symmetrically. So in this case, the axis of symmetry is the y-axis, so it's x equals 0. The axis of symmetry is also the x-coordinate of the vertex. It's always the x-coordinate, well, I shouldn't say always. In a function, it's going to be the x-coordinate of the vertex. Is this continuous? Yes, there's no gaps in this function. There are no breaks, no gaps, so it's continuous. We don't talk a lot about end behavior in Unit 3, but we want to say that this end behavior, as x approaches infinity, so as x approaches positive infinity, so as x goes this way, my graph goes towards positive infinity. As x approaches positive infinity, my graph goes towards infinity. F of x goes towards infinity, and the same thing as it goes towards negative infinity, the graph goes towards positive infinity again. So that's my end behavior. Okay, vertex form. Vertex form is another way of writing the function. And vertex form looks like this. Y equals a x minus h plus k. And our vertex is going to be given by hk. That's our vertex. It's the opposite of what's inside the absolute value and then the value that's being added. The a indicates the slope. If a is positive, then my graph, I have a minimum value, and my graph looks like this. If a is negative, then then it's upside down. My vertex is now a maximum, and so it's an upside down V. H indicates a lot of things. One, H is our axis of symmetry. It is the x-coordinate of the vertex. And it tells us how the graph is shifted horizontally. So it's a horizontal shift. If you have minus h, Then it moves it's going to move the graph to the right. If it's plus h, it moves left by that number of units. So if it's x minus 2, then it's going to move 2 to the right, 2 units to the right. K indicates the y-coordinate of the vertex. And it represents a vertical shift. If K is positive, it shifts the graph upward. If it's a negative K, it shifts graph downward. Okay, so that's the end of this video. Come back and we're going to look at, we're going to practice this. We're going to practice graphing a little bit. So watch the next video, please.